Hi everyone, my name is Jennifer Chandler from West Virginia University, and this set of videos that I'm producing is aimed toward West Virginia HSTA students, so high school students who want to have a basic understanding in statistics. So the first thing we're going to start talking about are data, because without data, how would we have statistics? So what are data? Data is a collection of observations that we use to answer a question. So, collection of observations used to answer a question. Okay? So that's pretty easy, right? We collect data to answer a question or to test a hypothesis that we have. Now there are a few types of data, but we're really going to concentrate on two because they are the data types that you're most likely to use in your HSTA projects. So the first one we're going to talk about is nominal data. So when you think of nominal data, think of categories of data. So they're very discrete packages of data. And some of the examples I like to give as nominal data types would be gender. So you can be male, female. Another one is survival. So did a plant or animal survive? Yes. Or did they not survive? No, they died. Another type of nominal data, very simply, could be a yes or no. It's kind of like survival, yes or no. Also population. So I could have a population of plants or animals from Kentucky, from West Virginia, from Ohio. But what you'll notice with these, with the yes or no, with the gender, with the population, is that my data is either one category or another category. It can't be both. It's not along any type of scale that could make it part from a Kentucky population, but also from a West Virginia population. They're in discrete areas. So nominal data are discrete categories of data. The other data type that you guys will be using quite a bit is continuous data. All right, and continuous data is also very simple. It's any variable or any observation between a minimum and maximum number. So what are some examples of this? Well, age can be a continuous data type. So age, because a person can be, anywhere from newborn up to, I don't know what the oldest person alive is now, but I would say in the low hundreds, right? So age is continuous. We could have a 2-year-old, a 13-year-old, a 67-year-old. So it's continuous. We don't categorize people into certain categories of age. You could do that, but for this we're going to stick to just a continuous scale of age. Another example would be leaf area, and I use leaf area in the work that I do with American ginseng. So I could have a plant that, for example, has a leaf area of 5 centimeters squared, 27 centimeters squared, even up, believe it or not, to 575, let's say, centimeters squared. So I have a very broad range of numbers that my data could take. So I have a continuous data type. Okay, another example of continuous data could be, for example, growth in terms of height. So however many 1 meter to 1.1 meters in height, that would be continuous data. So we know what nominal data are, we know what continuous data are. Before I get into a data set, let's talk a little bit about variables. Variables. So when we're doing our work, we're really going to focus on a couple types of variables. Our independent variables, which we call our x variables, and our dependent variables, which we call our y variables. So now what are the difference between these variables and what are the similarities? So one thing that's really important to keep in mind is that, let me change this color a little bit. Variables, both independent and dependent, can take on either nominal or continuous data types. So can be nominal or continuous data type. Okay, so we don't limit it to one or the other. We could have independent variables that are nominal, and we can have independent variables that are continuous, and same thing with dependent. So what is an independent variable? Well, in an experiment, our independent variable is the variable that we're manipulating. So variable we are manipulating. All right, our dependent variable then is not the one that we're manipulating, but it's the variable that is responding to our manipulations. Okay? So when we ask a question, not use green, how about? When we ask a question, we're often asking, how does x, which is our independent variable, affect y, which is our dependent variable? Now we'll get into question formation and how to run tests and ask questions about tests later, but this is just a little precursor to that. So we have independent variables, which are variables that we're manipulating, and dependent variables, which are those variables that respond to manipulations. All right, let's clear that out, and I'll get my pen color back. Okay, so let's talk a little bit about data sets, because data sets are oftentimes confusing to a lot of people. So let's just go through a very basic data set right now. So in our data set, we'll have on the far left observations or individuals, and that can be, as many data points as you have. But you always want to have as many observations as possible because that allows you to see real differences in the means of your different categories. So here we have, I've listed out 8 observations, but it could go down to as many observations as you want, which is n. All right, so let's take our first variable, and this is going to be our independent variable, x1, so our first independent variable. And we'll say that's gender. And let's say that we have 4 males, 4 females, and of course you would have more depending on how many observations you had. Let's say we want to have a second variable. So when we set up our data sets, it's oftentimes really advantageous to go ahead and put all of our data types and our variables in that data set so that we're not fumbling around looking for other spreadsheets. We know that everything is together. So this one's going to be drug dosage. in milligrams. And let's say the first 2 males got 50 milligrams. The second 2 males got 100 milligrams. And same with the females. First 2 got 50 milligrams. Second 2 got 100 milligrams. Down until the end of our data set. So these are our independent variables. These are the variables that we are manipulating. But what about our dependent variables, our variables that depend on these manipulations? So in our data set, we would have, variable y1, and I'll just put one y variable for now. And let's say that that is weight loss. Well, in pounds. Let's say the first male lost 5 pounds, the second male lost 2 pounds, the third male lost 0 pounds, the fourth 1 pound, and then we'll fill in some more information for the females. Okay? All right, so this is our data set. This is a complete data set, although of course we'd want more observations. So within this data set, one of these rows, one of these rows equals one total observation. So for this one individual, this first individual, we have their gender, which is our first independent variable. We have the drug dose they were administered, which is their second independent variable. And we also have their resulting weight loss, which is their dependent variable. So this would be our data set. But let's talk a little bit now about replication and observation number. So you saw on that last screen that we had 8 individuals listed out, though the observations could go however far we wanted them to. So let's kind of forget about that last scenario, because I'm not going to be using the same number of individuals in this one. But let's say that we have an experiment where we want to see if weight varies between 2 genders, males and females. So what would our independent variable be? Well, our independent variable would be gender, right? Because that's what we're manipulating, that's what we're changing, either male or female. So our independent variable is gender. Within that variable, we have 2 levels, male and female. Okay, so that's what we call levels. If this had been population, we could have had population as our independent variable, and West Virginia, Kentucky, and Ohio. That would have been 3 levels of this independent variable. Okay? Let's go back up here though. Let's focus on the top chart, and let's say we had 20 males total and 20 females total. So we're trying to see if weight varies among these between these 2 categories. So what's our total number of observations for this? Well, 20 plus 20 equals 40. So we had 40 total observations. However, we did not have that many replicates. So our replication was actually only 20 because we only had 20 females. We only had 20 males. So while we had 40 total observations, our replication was 20. All right, so this should make sense then. We have our independent variable, and we're trying to figure out how gender affects weight in males and females. We have 40 total observations, 20 replicates per level of our independent variable. So that's just a very basic overview of data and data sets. The real things to take away from this, perhaps the most important, are first, difference between nominal and continuous data. Also, the different types of variables are independent variables and are dependent variables. Okay. We're going to be talking in the next video about how to set up data sheets in Excel and how to transfer those over into the statistical program you'll be using, SAS Jump. So I'll see you then. Thank you.